Hi guys, nice to see you again. Today we are going to check our project before transferring it finally to our printed board. So we check our project on the breadboard to be able to transfer it next time. So what do we need for today? We need these two sheets from the last time. One is telling us what segment should we put on, and the second one is showing what segments they go to what terminal on our 7-segment displays. Let's start. You may have as your number 1 digit. If it is the case, maybe it's gonna be better to wait until we make the project with the big digit like this one. You may have it of 2 digits or 3 digits. You may even have 4. If you understood how to make 2 or 3 digits, you can extend it to any number you want. So then we're gonna pick up some numbers to deal with. Let's say we have here a kind of a random generator for numbers. The first digit on your left, you don't want it to be a 0, you don't start a number with 0, like the gas pump. So this one here is gonna start to count from 1 only, okay? So let's say it's a 3. I write it down. First is a 3. Next is gonna be the digit on the right side. Is gonna be a 4. And then, because I have 3 digits here, I'm gonna pick up another one, a new one. 3 is already there, we want a different number. 4 is already there, 7. And then, according to our paper, okay, I write them here directly. What segment you should put on? A, B, C, D, and G. For the 4, B, C, F, and G. For 7, A, B, and C. Very easy. So I write them down here, A, B, C, D, G. For the 3, B, C, F, G. For the 4, A, B, and C for the 7. And we're going to display the number 347, 347. Let's start. Our digit is, as you may remember from the last time we used, MAN 6760 is a common anode display. Common anode display, MAN 6760. The drawing for both common anode, common cathode are the same, just the common has to be connected in a different place. Common anode goes to positive, common cathode goes to ground. We use the common anode. So then let's start the connections. I have here the connections. I have to connect A. So I pick up a resistor, and A is the pin 7. So from the pin 7, I connect it to any blue line, because the blue line represents the ground. Okay. Then I'm going to connect B. B is adjacent to it, pin 6. Then I have the C. C is in the bottom, adjacent to the decimal point. All have to go to the blue line, because blue line is the ground. That was C. D is the pin 2. D is the pin 2. Right here. Okay. After D, we have the G. So G is on the other side. Is the pin 9 adjacent to the common. So if I just want to check this one to see if it's working, I connect the pin 8. I put it to a positive. It's a common anode. I check it, and because this one should have been a 3, I realize that
it should be on the G, which is the pin 10, it's not 9.
Okay, so we check it again. We have the 3. Next, it has to be the 4. Remember, it's always better to do connections with power off. So we have the B. B is right here. Last pin on the right, which is the pin 6. So we connect the B. Then we have the C, and C is adjacent to the decimal point. Have to be careful because you want it to make a good contact. I tried to short the resistors to look nicer when you do the wiring. Okay, so this was C. Then we have the F and the G. F and G are together, pin 9 and pin 10. So we connect them both to a blue line because the blue line represents the ground. Very good. And if we want to check it again, we connect the pin 8 to a positive and we check. So we have 3, 4. Last one is the 7. Power off. For the 7, we have A, B, and C. So A and B are the pins 7 and 6. So 7 and 6, they go adjacent to one another. Very good. And the C is the pin number 4. Pin number 4, close to the decimal point. Very good. Only 3 of them. And now we connect the pin 8, which is the common anode, and we check it. We have our number 347. Okay? And now we want what? We want to transfer this on our printed board, so we're going to do this next time. However, here we used independent resistors, and it's going to be much easier to use on our printed board another kind of resistor. I'm presenting it to you right now. It's something you may have not seen before. This is called a network resistor. It's a common bus network resistor. As you can notice, right here on the left side, it has a dot. And then, after the dot, you have a number of pins. Take a look what's inside. I'm going to pick up 2 examples. This one here, the dot is right above the pin common for all the resistors. As you can see, this one, it has 4 resistors. They are arranged like in a network. This is why it's called the network resistor. It's called common bus because they have one terminal related together. This is the common, okay? It has 1, 2, 3, 4, 5 terminals. 4 resistors, 5 terminals. Is the series of resistors 46, and then you have the number 5, 05, where the number 5 says how many pins it has. But this one has 4 resistors. What do you need actually? In case you may want to display the number 8, which uses all the 7 segments, you may need this one. 1, 2, 3, 4, 5, 6, and 7. So 7 resistors, plus the common. So if you count, you're going to have 4608 because it's 7 resistors plus the common is making 8 terminals, 8 pins. So far so good. I'm telling you this because you have to prepare the parts to transfer on our printed board. So we connect now a computer to look for these parts. We make here the list. You need, supposing for that particular version here with 3 digits, you need 3 common bus resistors. Let's say 330 ohms or 470 ohms. If you use this one, it's gonna be dimmer. If you use this one, the light is gonna be brighter. Okay, either of them is good anyway. Then you need 3 digits, 0.56 inches common anode digit, MAN 6760. Then you need 1 protoboard. This one here, that's what I found in my junk box. I'm gonna use this one 3 times 7 centimeter. If you just quickly measure it, you are gonna find out it's 3 by 7 centimeter. Very good. And you may also need a small connector. Let's say 1 2-pin terminal block to connect your wires to give it power. Okay, how do we connect all this together is next time, but now we just look quickly for the components. Okay, let's find out. We bring here a computer and we look for them. 470 ohm resistor. You have it right here. Common bus 8 pins, 7 resistors. It's approximately 70 cents each, and you need 3 of them. Okay, is this guy here. If you want the digit brighter, then you have 330 ohm common bus, and it's right here, same price, 70 cents. As you can see, 4608 because it has 7 resistors, but it's 330 ohm. Next thing you need, here is, if you type protoboard, oh, I forgot to tell you, I go on my favorite site for components, Abra Electronics, abraelectronics.com. Now the price is in Canadian dollars. You can get it in US dollars as well. So you go right here. And for instance, this one, it's exactly the one I'm looking for, 3 centimeter times 7 centimeter printed circuit board, approximately $2, okay? It's called BRD 230. Next, we go for MAN 6760. Here it is, approximately $1.5 each. You need 3 of them. And finally, you want this one. You type here terminal block, and you go here for this one. The model is called 2440P. Screw terminal block. You take a look. You don't only have one, you have a pack of 4. 5mm pitch is gonna fit exactly on the printed board. Okay? So for $2.3, you're gonna have 4 of them. That's what you need. So far so good? So see you next time in order to put all these things together on the printed board. Thank you very much. Bye-bye.